like this paper is a coil, and this is a plane of the coil. This is a plane of the coil, and if I want to show the perpendicular to the coil, so this is the direction, this is the direction of the normal or the perpendicular to the coil. Now the information can be given in two ways. Okay, like mostly this information of normal and all these things, they are used in the formula for the flux. Okay, if I say the phi equal to this BA and this is cosine theta, so this theta, this is the angle, this theta is the angle, this theta is the angle between the direction of the magnetic field, the direction of the magnetic field, and the direction of the normal. This is a direction of the normal, it is like that. Okay, now okay, so if I say, okay, now this is a plane, this is a plane of the coil, and this pen, this is a direction of the normal, this is the normal now. Okay, so if the information of the direction of the magnetic field I can give in two ways. So the two ways means the one, it is connected with the direction of the normal. Okay, like this. Now if I say, okay, if I say this pen, okay, if I say this pen, this pen, this one, okay, this is the direction of the magnetic field, this pen. Okay, now so this is a normal here. Okay, this is a normal. Now if I keep the pen like this, okay, if I keep the pen like this, this is the normal, this is the normal, and this is the direction of the B, direction of the B. Now this normal and this normal and this direction of magnetic field, they are parallel, so they are making the angle 0 here. This is 0 angle between, so the value of the theta is 0 in this case. Now if I keep like this, okay, this the normal is always here, this normal will not go anywhere, the normal never be like this, the direction of the normal always like this. Okay, only what will change, the direction of the magnetic field may change, but this direction will never change, all the time it will be like this, straight. Now if I take the direction of the magnetic field like this, okay, this way, so now this normal and this magnetic field, they are making the angle 90 degrees, so they are perpendicular. So this is one way to describe. Okay, and here the information is connected with this normal. Okay, so now if there is no normal, okay, if there is no normal, and here this is a plane of the coil, now this is a plane of the coil, now all the information will be in terms of the plane of the coil. So this is the plane of the coil, this is a plane of the coil. If I say, okay, this is the plane of the coil, this is a plane like a paper. Okay, now this pen is the direction of the magnetic field, it is not a normal now. Okay, so if I say like this, the direction of the magnetic field is perpendicular to the plane. So okay. Now if I say, okay, now if I say this is the plane, okay, this is the plane, okay, this is the plane, okay, this is a plane like this coil, okay, this is the plane of the coil, and this is the direction, this is the direction of the magnetic field. Now the magnetic field, this pen and this paper, okay, they are perpendicular now. The direction of the magnetic field, this is the magnetic field, and this paper, okay, this paper is a plane of the coil now. Okay, so they are not telling now the normal. Okay, normal, they are actually in the rule everything, okay, the angle we have to calculate with the normal, not the plane. Okay, but sometimes the information can be given with a plane. Okay, this is a plane of the coil now. So now in this case the direction of the field, this direction of the field is perpendicular to this plane. Okay, so what is the value of the theta in this case? So now what we have to do, first we have to, if they are saying like this, the direction of the magnetic field is perpendicular to the plane of this coil, so what we have to do, we have to draw the normal. Okay, now this is the normal now. Okay, sometimes we have to draw the normal from our side. Okay, so this is the direction of the B, and this is the plane. So the plane and this magnetic field, they are making 90 angle. This is okay now. But in the formula we cannot, okay, in the formula we cannot take this 90. We cannot take this 90. So what we have to do in this case, okay, in this, if it is given like this, okay, if it is given like this, the plane and the direction of the magnetic field, they are perpendicular. Okay, like this. So the meaning is the plane and this, they are perpendicular like this. Okay, if the plane and the direction of the B, they are perpendicular, the plane, not normal. So if they are 90 degree, okay, so in this case, if it is plane, so the value of this theta is 90. This is always 90. Okay, and minus this 90 here. So this will be 0. This will be 0, and this 0 will come here like this. It is 0 now. Okay, so if I see this from the diagram, okay, so this is the plane of the coil, and this is the direction of the magnetic field. This is the direction of the magnetic field. So from my side, I have to draw the normal. This is the normal now. Okay, so this normal and this, the direction of the B, they are parallel. Okay, the parallel means, okay, the parallel means this is 0. Okay, now, okay, other case, sometimes they can give like this is the plane of the coil, and this is the direction of the magnetic field, like this. Okay, so the magnetic field and this plane, okay, they are parallel. Okay, they are parallel. This paper and this magnetic field, they are parallel. Okay, so what angle you have to take now? Now in this case, this is the direction. Okay, this is the direction of the B. So we cannot take 0. Okay, there is a 0 angle. Okay, there is a 0 angle between the plane of the coil and the direction of the magnetic field. So 0 cannot be taken, okay, in the formula, no. Okay, so here what we can do, first I have to identify the normal. So this is the direction of the normal. This is the direction of the normal, and this is the direction of the B. Now they are making what angle? They are making the normal, this normal, and this magnetic field, they are making 90 degree angle. So in this case the value of the theta is 90. Okay, so if I draw here, if I draw like this, okay, now this is the direction of the plane, and this is the direction of the B. So what angle they are making? Okay, they are parallel. Okay, in this case, so this is 0 degree. Okay, they are parallel. Okay, plane, like this plane, and this is the direction of the B. They are making 0. So I'm writing here 0. So what theta you have to take? Theta, you in this case, this angle, okay, whatever is the angle between the plane of the coil and the magnetic field. So in this case you have to take 90, then minus this angle. Okay, so it is 0. Now it will come, okay, it will come 90 degree, like this, 90 degree. Okay, for example, if I say For example, if I say this is the plane, okay, this is the plane and this is the direction of the beam, and they are making, for example, they are making 30-degree angle. So what theta you have to take? So if it is with a plane, information of the angle, it is given with a plane and with the magnetic field, okay, like this. So what is the theta value? Theta is not 30 here, the theta is 90, in this case 90, and this angle minus, so it will come 30-degree here, and this will come 60-degree. So in this case the theta is 60-degree, like this.